Most people interact with artificial intelligence as a reactive tool. You type a prompt, it generates an answer, and it goes right back to sleep. But a different class of system is now operating inside modern enterprise. These are proactive entities that run constantly in the background, far beyond the confines of a chat window. This is an autonomous agent. It functions by connecting a core logic engine to external tools, a persistent memory, and a specific set of self-directed goals. To understand how these systems are changing the nature of work, we are going to build one of these agents from scratch. Mastering this anatomy allows a user to move past simple digital interactions and begin commanding a digital workforce. At the center of our agent is a large language model. It acts as a pattern recognition brain, using logical reasoning to solve problems word by word rather than simply searching for web links. You select this brain based on the requirements of the job. Models like Minimax are built for high-capacity memory, holding an entire book or an application's complete codebase in its active context without losing focus. If the task requires complex engineering, Claude can be deployed to execute multi-file software builds and debug code autonomously. For high-speed interactions, Gemini processes simultaneous streams of live video, audio, and text with sub-second response times. But to do real work, the brain needs a digital body. Systems like OpenClaw give the agent direct operational control over a computer. The agent can now move a mouse cursor, click buttons, and edit files on a hard drive. It navigates software and fills out web forms exactly like a human operator. Granting an AI direct access to the operating system turns it from a passive thinker into an active doer. Modern agents are also moving outside the monitor to perceive and interact with the physical world in real time. By connecting multimodal engines to smart glasses, the AI sees the user's perspective, analyzing physical movements and providing tactical cues through small speakers in the frame. They are also gaining the ability to communicate over physical phone lines. Speech-to-text tools translate human words instantly, while neural models clone voices with natural inflection and emotion. These phone agents can independently dial and negotiate with prospective leads, conducting full sales calls and updating a CRM without human intervention. This integration of sight and sound allows AI to operate as a collaborator in physical reality. To maintain long-term utility, an agent uses structured memory to learn a company's specific operating playbook and remember every past interaction with a user. We scale this intelligence by organizing agents into a swarm, a team of specialized bots. An orchestrator delegates tasks to developer and researcher agents working in parallel. A quality checker reviews the output. If it spots a mistake, it sends the task back for correction. Linking persistent memory with specialized swarms turns an AI application into an infinitely scalable department. When these components are fully assembled, an agent can identify a canceled order, issue a refund, and update warehouse inventory in under 3 seconds. It can respond to an online inquiry by calling the customer's mobile phone within 45 seconds to negotiate wholesale pricing. This level of orchestration and communication happens entirely in the background, executing complex business logic while the human user is away from their desk. As agents take over the individual steps of a project, the human role is changing. Success now depends less on the ability to write a single clever prompt and more on the ability to direct an entire autonomous workflow. The most effective professionals will manage AI as an autonomous teammate, integrating these systems into the core of how they operate.